In this part, we'll talk about the relation between the Cartesian XOY system and the curvilinear system NT. So how to find a relation between these two? In order to do so, we know that V vector is always tangent to the trajectory, so it's with UT. According to the rule, V vector equal V times UT vector. So, and also we notice that UT vector has also X and Y. يعني في كمان فصلها وبيطلع عندي X و Y لها. يعني it can also be written in terms of I and J. So the relation between the two systems must be found using UT, لأنه الUT هي اللي بقدر لاقيها بالأنتي system وبال XOY system using the rule اللي هي V equal V times UT vector. How to do so? Then we have now an exercise. You have here an object that is assimilated to a particle M in the XOY system such that its position vector is given by this relation minus 3ti plus t squared minus 1j. So the main questions are determine the velocity vector. So in order to find V, we know that V vector equals to R prime, and then we can find the value. And then the other question is determine the acceleration vector and find its value. Now in the part 3 is determine UT vector in terms of I and J. This is here the relation between the NT system and the NT system and the Cartesian system. So how to find this? So here the solution. We know that V vector equal to R prime, so عملنا derivative بيطلع لنا minus 3i plus 2tj, and the question is also find the value, so V equal radical minus 3 square plus 2t square, and then we'll have the value. The acceleration vector, A vector equals to V prime, so it's equals to 2j, since this is minus 3i derivative بتصير 0, and the value is equal to meter per second square. Now how to find the relation between UT in terms of I and J. هون هيدي هي relation between NT system and the Cartesian system. In order to do so, قلنا we use the rule اللي هي بتقول UT vector هي بالأساس V vector equals to V value times UT. And we also have, so نحن كنا طلعنا فوق الفector V وطلعنا الvalue V. So شو بعمل بس؟ نعمل بس substitution. Then in this case UT vector equal to V vector over V value. This is V vector هيها, and this is V value. We notice in this case that UT vector will be given in terms of I and J. هيك بنكون جمعنا system أو عملنا relation between system اللي هو NT system وال I and J system. Now in the part 4 the question is find AT vector in terms of I and J. In order to do so, كمان we know that the rule AT vector equals to AT value times UT. So first لازم نطلع ال AT كvalue. ونحن بنعرف إنه AT كvalue okay equal to V prime, the derivative of the value of the velocity. So AT equal V prime, and we know that V كان معنا نحن V بتساوي equals to radical 9 plus 40 square. So ما نعمل لها derivative. Then AT equal and عمل derivative, it will be U prime over 2 radical U. So بيطلع عندي AT over 2 radical U, and this will be the value AT. But the question is to find the vector AT in terms of I and J. So برجع كمان بعمل substitution. نحن معنا ال UT in terms of I and J طلعناها بالquestion اللي قبل, ومعنا ال value AT هيها. So بس بنعمل substitution. بس بديها at which time at t equals 0.5 second. So we substitute 0.5 second in the value here and in the vector UT. Then in this case we will obtain AT vector equal, this is the value AT times the vector. Then AT vector in terms of I and J equal minus 3i plus j over 5. هيك نحن إذا بتلاحظوا بنكون طلعنا tangential acceleration بس in terms of what? In terms of I and J. هيك بنكون عملنا relation between the NT system and the I and J system. Now in the part 5 the question is to find AN in terms of I and J. So we use the relation A vector equal AT plus AN vector. ليه؟ لأنه هو بده vector and not value. So ما بستعمل A equal radical AN square plus AT square لأنه بدنا here the vector. Then in this case AN vector equals to A vector minus AT vector. A vector كنا طلعناها, AT vector now طلعناها at t equals 0.5 second. So سايفين نقول AN vector at t equals 0.5 second. This is its answer in terms of I and J. Now how to find the value of AN? in order to find the value of an, so فينا نقول بكل بساطة a equal radical an square plus at square, and we have each part. So in this case we can find an. أو شو في استعمل هيدا الفيكتور اللي أنا طلعته وقول إنه an كvalue is equal to radical كل شيء قبل I square كل شيء قبل J square. So لازم أوصل لنفس النتيجة. So second method هي this is a vector. So عملت an equal radical كل شيء قبل I square كل شيء قبل J square, then we'll have the same answer. Now the acceleration vector can for t equals 0.5 second, لكن it can be expressed, this is a conclusion, it can be expressed يا بالكارتيجن system يا بالcurvilinear system. إذا بدي أعمل له expression بالكارتيجن system طلعت معي a vector equal to j، بينما إذا بدي أعمل له expression بالanti system بحط a vector equal at plus an, then we'll have this is at and this is an. So هيك بنعرف إنه ال a vector بحد ذاته بقدر أعمل له expression يا بالانتي سيستم يا بالاي جي سيستم. هذا اللي احنا كنا قلنا انه انا فيي اشوف فيي اطلع فاليو مثلا لمسافه بتساوي for example 2 متر، بس تقسيم هيدا المسافه بيختلف بين الاي جي سيستم والانتي سيستم. And this is here the main concept.